Hi guys. Um, I'm going to continue going over AMC 10, right? We were up to number 16. In the following list of numbers, now these problems were pretty, now we're getting into 16. These are going to start getting harder, probably might take, a longer time to complete. So I'll try to do them a little as quickly as possible, just so the video is not, I know the other videos were over 30 minutes long, so. In the following list of numbers, the integer n appears n times in the list for 1 to n to 200, right? What is the median number in the list? So you have 1, 1, 2 2s, 3 3s, 4 4s, 5 5s, etc., up to having 200 200s, right? And we want what number is in the middle. So first we should figure out how many numbers are here, right? Like what is the total number of numbers? So basically we have to do 1 plus 2 plus 3 plus 4 plus ... plus 200, right? But again, from my previous video, I explained that summing the integers from 1 to n is n plus 1 divided by 2, right? So in this case, it would be 200 times 200 plus 1, 201, over 2, which is 100 times 201, or 20100, right? So there are 20,100 numbers, right? Which is an even number. So that means we need to find the average of the two in the middle. So notice that if we split 20100 in half, we get 10050, right? 10050. Okay, which means that the median will be the average of the 10,050th number and the 10,051st number, right? So we need to find these two, or that's a th, over 2, right? So we need to find the 10,050th number in the list, right? But notice how, like, if we, like, so for example, like, if we sum up like 1 plus 2, that gives us 3, right? Which would tell us that the third number would be a 2, right? And then if we do 1 plus 2 plus 3, we get 6. That tells us that the sixth number is a 3. The seventh number would be a 4. So if we can find out what number, so we need to find out like what number n would result in having something that's 10,050 or higher. So we basically want to set up n plus 1 over 2 equals 10,050, right? Whoops. N squared plus n divided by 2 equals 10050. N squared plus n equals 20100. N squared plus n minus 20100 equals 0. So we have to kind of solve this quadratic. So, which does not look easy, right? That does not look like it. I'm just going to delete this because I need more room. So n squared plus n minus, so we need to solve n squared plus n minus 20100 equals 0. Maybe we can try quadratic formula and do n equals -1 plus or minus square root b squared 1 minus 4. Oh my god, so we're going to get an enormous number, right? All over 2. Well, 4 times 20100 would be, so we're going to have -1 plus or minus square root 1 plus 80,400, or 80,401 all over 2. Now, obviously, we can't use the minus here, so we'd have to have the plus, because otherwise it'd be negative. N needs to be a positive number, right? So we need to figure out like the square root of 80,401. So, well, here, let's think about this for a second. If we do 300, oh wait, no, sorry, because we want to know what number that would be. 90,000, because 300 squared would be 90,000, right? So clearly, right, that would be too high. 200 squared would give us 40,000. So it's got to be between the two. What's 250 times 250? 250 times 250 is 25 to 25 is 625. So that'd be 62500. So that's too low. What about 260 times 260? 26 times 26. That would be so 25 plus 1, 25 plus 1 plus 51. So 625 plus 51, 676. Right? So it's still, again, too low. What's 28 times 28? So 28 times 28 is 784. 29 times 29 is 841. So it's between 280 and 290. So 280, let's try 285 and see. 285 times 285 is 81225, too big. 284 times 284, 80656. That's too big still. 283 times 283, 80089. So this number is in between 283 and 284. So it's between, so 283 minus 1 would be 282, and 284 minus 1 would be 283. So n is in between 282 over 2 and 283 over 2, which would be 141 and 141.5, right? So it's a little bit bigger than 141 essentially, right? Remember how we said that, like, the sum of the, like, if the sum of the first n numbers is, let's say, 6, like 1 plus 2 plus 3 is 6, so that means the sixth number would be a 3, the seventh number would be a 4. So if n is 141, then it's actually going to be, because it's a little bit bigger than 141, right? Because it's right, it's in between 141 and 141.5. So the answer must be 142, which is choice C. Okay. That one's annoying just because of the math you have to do without a calculator. So that, yeah, that one's definitely pretty annoying. Yeah. Okay. All right. So like I said, these take a little longer. So, okay. Number 7. Okay. Now this is the problem that gave me the biggest headache, and I worked on this for hours and hours on hours. And it it's funny, it turned out that there was one thing that I was missing that made it possible, right? And actually not terrible. It's still a pretty bad question, but there's one thing that I wasn't thinking about. So I'm going to do my best to just kind of draw the situation. It's kind of hard to draw, but I'm going to start by drawing it, and then I'll just sort of explain what I'm doing. So basically, this is O, and then we have P is in the center, and then I drew this line, and this is 11, and then since P, okay, so basically the idea is you have a trapezoid, A, B, C, D, right? AD is perpendicular to BD. O is the intersection of the diagonals, so that's O is over here, right? P is the midpoint of BD. OP is 11, so you can see I wrote 11 there, right? The length AD can be written in the form m square root n, where m and n are positive integers. N is not divisible by the square of any prime. Basically means it's a simplified radical. What is m plus n, right? So I called this, so I'm going to use a different color to kind of show this. So I called this distance x, and then I called this distance x plus 11, since P is the midpoint. right? So the key thing that I was missing in solving this problem is the fact that because triangle BCD, right, is isosceles, that means that the median CP, right, because CP cuts the base in half, must also be perpendicular to the base. So that angle is 90 degrees, right? So that's something that I kind of forgot to realize at the time. So what I did was I set up a couple of unknowns. I called AO, I'll just call it A, right? So distance AO. AB I call, OC I called B, and AB I called C, right? And I'm gonna actually try to make this a little bit smaller just so because I'm gonna need some room to do some algebra here. So now one thing you wanna notice is that you have several similar triangles here, right? Because if you think about it, this angle equals this angle because of parallel, right? And then you have this angle equals this angle, right? Just here to here, not the, let me draw that a little bit better. So basically like you have like this angle equals this angle, right? Then also you have, let me get a different color here. Let's take it. Okay. We have this angle equals this angle because, right, they're vertical. And then you have two 90-degree angles. So triangle ADO is also similar to triangle CPO. Right? So basically then this angle must equal this angle, right? So now, okay, so I'm going to kind of show out what I ended up doing, which again took me forever to really eventually realize. So starting with the fact that triangle AOB is similar to triangle COD, right, by angle. So what that means is x over b equals x plus 22 over a. Right? X over b equals x plus 22 over a because of the similarity, right? All right, so does that make sense? So therefore, a is equal to b times x plus 22 over x, right? So what that does is that gives me an expression for a, right? So what I'm going to do is just, instead of putting a, I'm going to write b parentheses x plus 22 over x. So that gives me, right? Now, I probably want to see if I can get an expression for b. Okay, so now I'm going to erase this again so I have a little more room here, right? So now, from the similarity of triangle ADO, right, this right triangle here, and CPO. So triangle ADO is similar to triangle CPO because of angle, right? So therefore, B over 11 equals X over M root, sorry, is that what I wanted? Equals A over X. Oh, okay. So so then what I did was, so B over X will equal, no, sorry, B over 11 will equal A over X. But remember, we found a new expression for A, right? We found an expression for A in terms of B, which is bx plus 22 over x, right? Because then we have b over 11 equals bx plus 22 over x, right? So again, coming from the similarity, which hopefully this will allow us to solve for x. So we have b over 11 equals bx plus 22 over x squared, right? Cancel b's out. This is a 1. Okay, I'm gonna move this up so I have more room. So then by cross multiplying, I get 11x plus 11 times 22 equals x squared, which gives me a quadratic. 11x, x squared minus 11x minus 11 times 22 equals 0. Oh, that should be just at x, not x squared. Right? So now to solve this quadratic, I can just sort of, factor. And notice how this is 11 times 22. So I can make this x minus 22 x plus 11. Right? Because the difference is negative 11, and they would multiply to negative 11 times 22. So therefore, x must be 22. So now I have an expression for x, right? So now I know that x is 22. That's going to make my life a lot easier because, right, that's one less variable I have to worry about. So now I know x is 22. And again, I know this problem's crazy, right? X is 22. So then what? So then now we can set up one more similarity because we need an expression for C. So by looking at the similarity of triangle ABO and ODC, right? I can also say C over x plus 22 equals x over 43, right? Which I can just, so then I can say C equals x times x plus 22 over 43. But remember, we know x is 22. So that's going to be 22 times 44 over 43, right? Right. So then 43. So then what do we know? So x is 22 times 44 over 43. So now what I can do is kind of replace this. So this would be 22 times 44 over 43. And then, so now what I can do is, and again, I also know what x is. So I can now use Pythagorean theorem to solve for the missing side. Right? Because I know that, so this side is x plus 11 plus, so it's 2 times x plus 11, but x is 22. So that's going to be 66, right? So dB is 66. So I can say 66 squared plus m root n squared equals, and then 22 times 44 over 43, 44. So that's going to be 2 times 44, so that's 88. Oh, sorry. I think I put 44. I meant to put 43. So that's okay. 43. I think I made a mistake earlier when I did that similarity thing. Because basically it was x over 43 equaled x plus 22 over c. So c equals 43 times x plus 22 over x, right? Yeah, I think I made a mistake. So by plugging in 22, you get 43 times 44 over 22, which reduces, so that should be 86. So C is 86, right? This distance here is actually 86. Yeah, I think I just made a mistake before. So what that tells me is that it's a lot of erasing. I can just use my, okay. So then this is going to be 86 squared. So then m root n is equal to the square root of 86 squared minus 66 squared, which is 86 plus 66 times 86 minus 66, which square rooted, which is square root of 20 times 152, right? So then so we can factor out a 4, right? That's 4 times 5 times 152 is 4 times 25 and 13, so that'd be 37. 25 and 13, 38. So that would be 38. So 4 times 38. So what we'd end up with is we would have 4 root 5 times 38. 5 times 38 is 190. So the answer is 4 root 190, but the question wants m plus n. 4 plus 190, 194. So I'm sure you guys can see why that question drove me absolutely insane. And the key thing, and again, the key thing that was keeping me from solving it was realizing that this was PC was perpendicular to DB because this is an isosceles triangle. So that's what was, so once I realized that, it was actually possible to solve it. But anyway, I'm going to move on. I'm going to do up to 20 in this one. Okay, now this one was really weird. Let f be a function defined on the set of positive rational numbers with the property that f of a times b equals f of a plus f of b for all positive rational numbers a and b. Suppose that f also has the property that f of p equals p for every prime number p, for which of the following numbers x is f of x negative. So yeah, this one was really weird. I remember kind of trying to figure out what this function was all about. So I'm just trying to look for my notes here. So I have 14, 15. Okay, here's my notes for this one. So like, okay, f of a times b equals f of a plus f of b, but also f of any prime equals itself. So whoops. So so f of 2 equals 2, f of 3 equals 3, right? So, but now if we think about it, what's f of 1, right? What's f of 1? F of 4 would be 4 because it'd be f of 2 times 2, which would be f of 2 plus f of 2, 2 plus 2, 4, right? F of 5 would be 5, f of 6 would be 2, f of 2 plus f of 3, which would be 5, right? Whoops. F of 7 is 7. F of 8 is f of 4 plus f of 4, which is 4 plus 4, 8. F of 9 would be f of 3 plus f of 3, which would be 3 plus 3, 6. So we can kind of start figuring those out, but look, like we're looking at fractions, right? Can we figure out what f of 1 is? Well, if you think about it, like f of 2, right, equals f of 2 times 1 equals f of 2 plus f of 1, right? But f of 2 equals 2, right? So, and also the f of 2 equals 2. So 2 plus f of 1 equals 2, which means f of 1 must equal 0, right? So basically the key observation here is the fact that f of 1 equals 0, right? And we're going to use that to figure out which of these could be negative, because if you think about it, like what's f of 1 over any number, right? F of 1 over a. Well, f of 1 over a equals f of, or here, let me put it in a different way. So f of 1, which we know is 0, would equal f of a times f of 1 over a. Or sorry, not times. Let me undo. F of a times 1 over a, right? So, which would be f of a plus f of 1 over a. So what does that tell you? Well, that tells you that f of 1 over a for any integer a equals negative f of a, right? So, right? Does that make sense? So f of 1 over a would equal negative f of a. So f of 1/2 would equal negative 2. F of 1/3 would equal negative 3. F of 1/4 would equal negative 4, etc., right? Now, another observation that we can make is, what about f of a over b, right? What's f of a over b? Well, if you think about it, f of a over b is f of a minus f of b. Because f of a would equal f of b times a over b, or f of b plus f of a over b. So therefore, f of a over b would equal f of a minus f of b. So then what we want to do is we want to look at each of these fractions, right? And think to ourselves, like, what would it happen if we did? So here, let me just, I'm trying to erase and it just takes forever. So for example, what would be f of 17 over 32? Well, that would be f of 17 minus f of 32, right? But f of 17 is 17 because it's prime. F of 32 is f of 4 times 8, right? But f of 4 is 4, and f of 4 plus f of 8. But f of 4 was 4, and f of 8 was 8. So that would be 12. So that's going to give you 5. So that's not negative, right? So we'd have to go just through each answer choice and figure out which one would work. So to save time, I'm just going to go right to the correct one, which is D. So f of 7 over 6 would be f of 7 minus f of 6, which would be 7 minus, oh, no, I'm sorry. No, sorry. The answer is E, sorry. So f of 25 over 11 would equal f of 25 minus f of 11. Now, f of 25 is f of 5 plus f of 5, which is 5 plus 5. And f of 11 is 11. So that would be 10 minus 11, which is negative 1. So E is negative. So this question's like not super hard. It's just hard to kind of understand things. Like anytime there's like a function of multiple variables, it gets a little confusing. Because there's so many different possibilities, and like you're kind of thinking about positive numbers, and then all of a sudden you're starting to see fractions, and it's like, what the heck, how am I supposed to get like a fraction out of this? Like a times b, but these are like divided by, right? So, but anyway, yeah, so that's how you do that. Okay. Number 19. I remember hating this one with passion. This was another one that took me a while. So I think what I'm going to do, again, in the interest of saving time, is I'm just going to kind of go straight to graphing what this thing actually looks like, which is hard to realize what this thing looks like. Anytime there's absolute values, I always get thrown off. I'm just not great with absolute values. But one thing that I did think about when I looked at this is I saw x squared plus y squared. So whenever you have something that's like x squared plus y squared equals 9 or 25 or 16 or some number, right? That's always a circle with radius, whatever this value is, the square root of whatever this is, right? So this would be a circle radius 3, circle radius 5, circle radius 4, right? So I kind of knew there was going to be circles involved in this, um, but I couldn't quite see what this was going to look like. But um, so what you might want to do though is when you're looking at like absolute value of x minus y, right? Um, so I think kind of what you want to do is you might want to think about it in different cases, like the case where x minus y is positive and x plus y is also positive, in which case the absolute value bars are unnecessary, right? And if you do that, then basically x has to be bigger than y, right? Which happens when you take the line y equals x, x is bigger than y over in this region over here, right? Um, so yeah, so then so let's like pick a value. Let's see what would be the value that would be on the line itself. Would be 3, 3, right? Um, is 3, 3 on this function? So you'd have 9 plus 9, 18 equals, this would be 0 plus 3 times 6, which would be 18. So 18 equals 18, yes. So we can start with the point 3, 3, right? What happens on the x-axis itself? On the x-axis, so y is 0, right? So you would have x squared equals 3 absolute value x plus 3 absolute value x, right? But obviously x would have to be 3 for that to work, right? So then you would have oh no, that wouldn't work. X equals 6, right? Because then you'd have 36 equals 18 plus 18. So this has to be 6, right? And then if we draw the line y equals negative x, right? We would see that we could have the point 0, 3, negative 3, and then we'd end up having negative 0, negative 6, negative 3, negative 3, negative 6, 0, negative 3, negative 3, and then negative 3, 3, and then 6, 0. So you're kind of seeing this, and you're probably thinking like, oh, it's some kind of a diamond shape. But actually, remember, it has this kind of circular form. So it's going to make sort of a circle here, a circle here, a circle here, and a circle here. So it makes this kind of a shape. This is very, 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 very tricky. I don't know how anyone's really supposed to know that that shape looks like that. Um, yeah, so I mean, this is probably one of the harder problems on the whole thing, just because you're supposed to somehow understand that what this function looks like, right? But once you do know what it looks like, then you can kind of set up a little. It's actually not that hard because this is sort of a rectangle in here, right? And it's a rectangle that's basically 6 by 6 or 36, right? And then you have 4 half circles of radius 3. So you have 2 circles of radius 3. So you have 2 pi 3 squared, 18 pi, right? So overall, the area is 36 plus 18 pi, right? And they said m plus n pi, they want m plus n. 36 plus 18 is 54. So the answer is 54. This one's really hard because you'd have to have some knowledge of like polar coordinates to really understand this. I actually tried using calculus and still struggled to really find it. Yeah, this involves like a pretty substantial knowledge of polar functions, which is not something that you're usually taught in anything before IB math. And even then, we don't do it that much. So I can understand if people really struggle with this question. Even myself, I did. All right, now number 20, these are my favorite types of questions, the counting problems. Right, so basically you had to kind of figure out all the different possible patterns that you could create. Right, so it says, in how many ways can the sequence 1, 2, 3, 4, 5 be rearranged so that no 3 consecutive terms are increasing and no 3 consecutive terms are decreasing, right? So Yeah, so, okay. Sorry, just give me 1 second. So this is 10 plus 1, 2, 3, 7, 14. So that's 24. 24 and 8 makes 32. But why did I? Okay. So I think what I did was I tried to figure out all the possible patterns. So basically, like if you think about, that is not what I wanted to draw. If you draw like, say these represent 1, 2, 3, 4, 5, right? So you need to make it so that no three numbers in a row are all increasing or decreasing. So you always have to be going like up, down, up, down, up, down, or down, up, down, up, down, up, right? So like one example would be like, say you start at 1 and then you go to 3 and then you go to 2 and then you go to 5 and then you go to 4. That'll work, right? So 1, 3, 2, 5, 4 works, right? Sorry, I need to be able to, yeah, okay. So sorry, I'm gonna leave that. So 1, 3, 2, 5, 4 would work. Also, you could do 1, 4, 2, 5, 3, right? 1, 4, 2, 5, 3. Okay, you could do 1, 4, 3, 5, 2. You could do 1, 5, 3, 4, 2, right? Yeah. So, okay, so then you could have 1, 5, 2, 4, 3, or you could have 1, 5, 3, 4, 2. 1, 5, 3, 4, 2. So those are all the possibilities that would start with 1, and you can kind of convince yourself that those are the only. So you can kind of see my system was to go like increasing, like going by the second number and finding all possibilities with that being the second number. Obviously 2 can't be the second number because then you can only go up from 1, 2. So that's why you can't go 1, 2, right? Okay, so that would be all the cases starting with 1. For 2, you could have 2, 1, 4, 3, 5. You can have, I'm just going to kind of write them. You can have 2, 1, 5, 3, 4. And again, I'm doing my same strategy of looking at what the second number would be, right? You can do 2, 3, 1, 5, 4. And notice how it's only possible if you do 2, 3, you have to go back to 1, right? So that's the only one with that. 2, 4, 3, 5, 1, 2, 4, 3. I'm sorry, I think 2, 4, 2, 4. Okay. 2, 5. No. 2, 4, 3, 5, 1. 2, 4, 1, 5, 3. 2, 5, 1, 4, 3, and 2, 5, 3, 4, 1. So those are the ones that start with 2s, right? So here I'm actually gonna just erase this because I think you guys kind of get the idea of what this was about. Right now, all the ones that start with 3s, 3, 1, 4, 2, 5, 3, 1, 5, 2, 4, and same strategy looking at the second digit, 3, 2, 4, 1, 5, and 3, 2, 5, 1, 4, right? So then what I did was now instead of trying to find all the ways that start with 4 or 5, I realized that they would just be symmetric to these, right? Because it would just be like the same pattern, just backwards. So each of these got multiplied by 2, right? So far I have 1, 2, 3, 4, 5 times 2, so that's 10. Then I have 1, 2, 3, 4, 5, 6, 7 times 2, 14. 1, 2, 3, 4. So that brings me to 28 so far. Right? But I also need to multiply 14. I also need to multiply these by 2 because similarly, I could, instead of going 3-1, I could go 3-5. And instead of 3-2, I could go 3-4. So each of these could also be symmetrically backwards as well, because these are starting from the middle, right? So what I tried to do is I tried to find half the cases, essentially, and then just multiply it by 2. So these are all the cases where you start from the left and go right, start from 1 and go right. These are the cases where you start from 2 and go right. These are the cases where you start from 3 and go left. So these times 2 also to consider the cases where you start in the middle and go right. These can be flipped to start at 5, and these can be flipped to start at 4. So each of them gets multiplied by 2. So it's actually plus an additional 4 because this is times 2. So that gives you 32 possible cases, right? I'm sure that's not the best way to do this problem. I'm sure there's like a much more systematic way to do it, but it was kind of the only way that I can come up with at the time. So of course I'll try to think of a better way, but if any of you have a better way to solve this one, please let me know. Okay. All right, so I'm going to end this video here. It's probably crazy long. I'm sure nobody really even watched this far, but even if you just want to see the answers, that's fine. All right, so my last video is going to be 21 through 25, which is probably going to take forever, unless I even break it up even to smaller pieces. But I actually didn't find any of the last 5 too crazy hard, believe it or not. I think we've actually done the hardest one so far. So, all right, see you next time.